The topics we're going to cover the slave setup, which the hardest part is actually getting the data set. Topics covered, so the biggest thing is getting the data set, and we're going to go over LVM snapshots, ZFS snapshots, locking tables, and using MySQL dump, the logical export tool, using to be hot backup, and also MySQL hot copy. We're also going to look at what other information we need for the setup, what causes a slave to get out of sync, and then how to sync a slave with its master. The first thing we're going to cover is taking a snapshot with LVM. LVM is a logical volume manager. It's on Linux servers, and what it is it's something that sits kind of on top of the file system, but it's kind of on the file system level. So you have to actually, when you format your partitions, you have to format them such that they can use LVM. If you already have like a file system on it, and you have MySQL on it, and it's not set up for LVM, you have to like reformat the system. So it's not something that you can just kind of add, although you can if you have extra disk, and you can reformat on that extra disk. So there are logical volume managers. So there's regular physical volumes, your disks, and then there's logical volumes. So what LVM does is it is a way to merge more than one disk to form one logical volume. So for example, if you're using partitions, you can think of a partition as a logical volume of a disk, but then you can only have partitions be a subset of one disk, right? So if you have a disk that's 500 gigabytes, you can have two 250 gig partitions, but you can't have a 700 gig partition because that's bigger than one disk. With LVM, you actually can have like a mount point that's 750 gigs if you can combine more than one disk.
All those disks should be on the same machine, or they could be on the network?
They should be on the same machine. They can be like on the network if you're talking about. Usually, if they're on the network, they're on some kind of SAN, like a NetApp, and you have something like LUNs. But a LUN is basically a logical volume. It's just there's different names for it, and it's probably not using the same technology.
Would it be possible to have a folder or even a file that exceeded the size of the disk? Would it do the right thing and split it across them?
I have no idea. Well, that's a great question. If you have a folder that's bigger than like a disk, or a file that's bigger than a disk, would it do the right thing and split it across the partition with it split across the logical volume properly? I honestly don't know. I don't know if that's not generally a problem, I guess.
Is the LVM consistent with all Linux editions, or is it all different everyone? Where they do LVM?
I think it depends, because
Okay.
I think the code is the same, but like CentOS, the Red Hat will repackage things sometimes, and Debian repackages things sometimes. Like if you look at the MySQL source code, or MySQL binaries for Ubuntu and Red Hat are the same, but the Red Hat repackages it and Ubuntu repackages it, so they end up acting differently. So,
Okay.
Yeah, and there are different versions that go on different packages as well. So it's not a drop-in replacement. If you blow up your Fedora Core 10 install and say, oh, screw this, I'm going to Ubuntu, if it's not a compatible version of LVM, you won't be able to mount the partitions. You'll have to reinstall FC10, get the data off, and then...
right, but if you have version, 7.12 of LVM on Linux, is it the same on Red Hat? Is the same as 7.12 on Ubuntu?
My understanding it is, because we used to
Yeah.
mount LVMs on multiple OSs that had consistent
Well, there you
LVM
go.
versions.
So then it should be.
Okay.
But again, like I said, you get tired of Fedora and you go to Ubuntu.
You gotta know what you're doing.
Yeah, the versions have to be the same. The other thing you do, if you're if you're not faint of heart, is just compile it. Take a big deep breath first.
So what you do is you take your physical volumes, that'd be your disks, like dev-sdb1, dev-sdc1, and dev-sdd1. These are 3 separate disks. And you merge them into a volume group. So this volume group is, say, dev data. And then you can have mount points from that, like dev data logical 1, dev data logical 2, dev data logical 3, and then you have some free space that you haven't mounted yet. Now that's important, because when you take a snapshot, you need some free space to copy the snapshot too. So we'll get to why would you ever leave free space. It's actually a pretty good idea. So that's basically how LVM kind of works. It's a little more complicated than that. Do you have something you want to say, or
I
you
was
just...
agreeing.
Oh, okay.
Yeah.
Great. So the LVM snapshot, so the snapshot itself doesn't use all these commands, but you're going to need these on your way to there. So PV create and PV display is your physical volumes. That's to create your volume group. So if you wanted to create the volume group, you'd create it and you would say, oh, put in SDV1, SDC1, and SDC1. PV display shows you things. VG create, again, that would create your volume groups. So you have to actually name your physical ones. Then you make your volume group with VG create and VG display. And then you have the PV, the LV, which is your logical volume create display, and then LV extend. So that's another neat thing is that if you have this, it's 140 gigabytes, and you say, oh, I want it to be 300 gigabytes, you can do LV extend, use some of the space from this free space, and put it right there, which you can't do with normal partitioning.
I mean, a big thing to keep in mind with the LVM stuff is that you start off with a handful of partitions, like on Dev SDA2 and SDB2 and those sorts of things. For all intents and purposes, once you start creating the LVM, those devices don't exist anymore.
Right.
And then you create an LVM that is a single device that lashes all the individual partitions together. And then you start building on top of that. But the idea that your data is stored on SDB or SDA or SDC, those devices don't exist when you're saving files on an LVM. And yes, there are disks there that eventually will end up on one of them, but you don't get to decide which one it's going to go on directly.
Right.
Well, if you have a bunch of different disks, unless you're on the underside, there's some kind of RAID going on hardware. You get all the failure of all the disks, and the LVM doesn't do anything to correct for that. So if one of those disks goes, it's not like a RAID where it's going to fix. It's your entire LVM is gone.
Or you can build a RAID and then put the LVM
Yeah.
on top of it.
Right.
That's the other thing
Yeah.
to do.
LVM doesn't do any redundancy though. You're absolutely right. If you want redundancy like as in a
Yeah,
RAID
so-
array, you have to build that in as well.
Yeah, using a bunch of off-the-shelf cheap disks to build a large LVM is, without doing something underneath it, is kind of dangerous.
Yeah, exactly. So
Well,
that's-
if you don't
that's a
care
good
about your
point.
data, then it's really not.
Well, true.
So file system considerations. Some of the file system considerations, if you have something like XFS or RiserFS, they make it easy to resize partitions on the fly. So you might think, oh, I don't need LVM because I can already resize my partitions on the fly. And LVM does actually add some overhead to everything because it's got to manage these groups and whatever. But so does a journal file system like ext3, right? If you're using ext3, that adds a little bit of overhead, but it's for a good cause. So just to kind of let you know that. So. The LVM snapshot, it's an almost hot backup. You basically have to lock, so you have to lock your tables, so you do flush tables with read lock. And then you have to create, so you're doing LV, so your logical volume create, so you're saying create a logical volume, dash L is 5 gigs, so the size is 5 gigs. I forget what S and N are, snap, but here's the volume group name, it's dev VG name data. So you're basically saying, create this, it's creating the group with the snapshot. So you're basically saying create it, and then you're going to be putting the snapshot there. And then you unlock the tables. So when you do this flush tables with read lock, first of all, the reason you do show master status is that you want to know where you are in the binary logs when you're doing this. So you've locked it, nobody can write to any of the tables because you flushed all the tables with a read lock. You've done a show master status. In a different process you have to do this, because if you exit the MySQL at this point, your flush tables with read lock goes away because it's a session only thing. So if you end the session, it goes away. So you have to keep this open, create this, and then unlock the tables. But this happens very quickly, and so basically what happens is after that, so that's why it's almost hot, because you do have to lock it, but it's for a split second. Most places don't have a problem locking for a split second. The biggest thing comes here where now you're mounting that this logical volume that you've made. You're mounting it to an actual mount point, and then you copy the snapshot, which you had mount snap, which was over here. This is the snap thing. You're copying from the snapshot. Which is a temporary place in the, it's a temporary snapshot. It's not going to stick around, so you need this extra space here. So you're going to copy it to here, to this. It says slave IP, but yeah, I guess you could do that. You can also just do a regular copy onto it, and you have to wait. But this is specifically showing you how if you wanted to copy the backup directly to a slave, you could do that. But basically, once you take the snapshot, you have to put it somewhere. Otherwise, you'll lose it because it's just it's a temporary snapshot. So what we do here is we're copying it directly to the slave that you want to set up. You don't have to do that. You can actually copy it right to a mount point. This step will take a while, and whether or not you're doing an SCP to a remote slave or you're doing a copy, just to a local directory, this can take a while. And it does add overhead. And the biggest problems we've seen with people using snapshots, whether it's LVM or even ZFS, is that copying takes a long time. Even in a regular backup, if there's a cold backup taken, which we'll talk about later, or some tool is used to get it, the biggest overhead that we've seen is if we're going to SCP it off to another server, that ends up producing a lot of load on the server because the server is using its CPU to do the copy and not for MySQL. So
I'm sorry, the purpose of using the LVM is just so you can lock your database very quickly, take a snap, and then unlock it.
exactly.
If you don't have a LVM or something like that, you would need to do that copy, wait all that time, then unlock your database.
Right, you would have to basically lock your tables, take some kind of an export, whether it's a physical copy of the databases or a logical export with MySQL dump, and then resume that. If you want a consistent backup, which that's what we're going for with your slaves, because you want to have a point in time. You want to have, this is what my data looked like at a point in time. If you have regular backups that you want to use, you can do that too. It's just you're going to need all this information anyway. Some people will do an LVM snapshot every day, and that's why you want the show master status here, because you want to know where you were in the binary logs. Now, you don't necessarily need the show master status if you have the binary logs themselves. You know what position you were at because you were at the end of that binary log. But if you, one of the things that if you also do, say, a flush logs, it will flush the binary log. And you could say, okay, if you take, like, say, a backups at 6 a.m. every morning, you can say, okay, let me take my backup at 6 a.m., start at the binary log that was rotated, right? So the binary log that starts at 6 a.m., I want to go from there up until this point in time, up until now, and restart that. So, then you unmount your snapshot and you can remove the snapshot because you've copied it over to another directory. So basically all of these 4 steps, they have to be done in this specific order. You can't mount the snapshot before you've taken the snapshot, that kind of thing.
So, Shiri, but how that data came into snapshot so quickly? You talk about split seconds. So
I honestly have no idea. It's magic to me. I really don't know how does it take that snapshot in.
right, that's what kind of bothered me when I
It probably does something like a journaling system where it takes us, it doesn't really copy it, it probably just says, okay, any changes that happens to any of these files has to be written in a different place.
It implements it by a copy on write scheme. So basically, the operating system or the LVM layer remembers, here's all the blocks, and if no application writes it, then that copy can just copy out of the blocks as needed, right?
So in
But
reality,
if somebody writes into one of those blocks, then that block gets the original block that you had gets copied somewhere over to the side.
So the priority is whatever's being written now.
So that now there's 2 versions, right? There's that block and this block. And the snapshot refers to this block, and the currently running MySQL daemon refers to this block. And when you drop the snapshot, it just drops those blocks on the floor. This is basically a technique that's used, for example, when you memory map a file, like the way the linker works is it memory maps the data that it's linking in. And then if you change it, it copies it as needed, so that you get this instantaneous link, but then if you actually change things, then you get private copy, for example.
So that's
Classic
another,
technique.
yeah. Great, well, that's another
Goes
reason why,
back to multics.
why things might be slow, because if you're doing a lot of writes, right, it has to copy all those blocks, so.
Yeah. The first write's more expensive than the second one, because the first one has to create that new copy. And if you overwrite the block again, then it doesn't cost anything.
Right, but if you're writing to different blocks,
And if you're writing to different ones, and you have to have some space over on the side.
right, that goes back to our our free space back over here, you have to have some free space. Otherwise, a lot of times we're like, oh, we'll partition. We want to make use of all our space, so we'll partition everything. But you can't do that.
So it leaves some set of blocks for the older data and starts to write the newer data into different set of blocks, and
It
that's
actually
why
runs-
how it preserves.
It actually copies the old data into the temporary space, so that when you drop the snapshot, it doesn't have to do any additional work. It's got the most up-to-date data is in place. So, but you could do it the other way. That's how LVM works.
Great. Better. So ZFS snapshot is very similar. The commands are different, but again, it works similarly. Flush tables with read lock. I actually deleted where it said show master status because I put that on the next slide. But ZFS snapshot pool name, part name, at date. So basically take the snapshot, and here's some information about taking the snapshot. Unlock the tables. So again, it's a split second. Take the snapshot, unlock, lock the tables, take the snapshot, unlock the tables. Copy stuff off. Again, we're copying the slave IP, but you could just copy locally to a mount point that's already there for your backups, and then destroy the pool, destroy the snapshot. Say, okay, I'm done with it. And again, must be done in the specified order. It's the same four steps. So for any snapshot, make sure you get binary log positions for the machine itself with show master status. Again, if you end up getting the binary logs themselves and the bin.index, like master bin.index, you don't necessarily need show master status, but you need to make sure that you know where that is, because if you're setting up a slave, right, if you have a machine, you say I want to set up a slave of this machine, you need to know where to start in the binary logs. So on this machine, you say the snapshot was taking at this such and such a time, so start at that time and only go forward. Also, sometimes what you end up doing is you have a slave and you want to make another slave. So what you can do is you can take a copy of the slave and say, okay, let me take the data on the slave and put it here, but instead of making this a slave of this machine where I took the backup, I want to make it a slave of the same machine that that was a slave of. So this way you don't have to do a backup on your master server. You can do it on your slave server, right, assuming all the data is in sync, which we'll get to later, right? So you take your slave server, you make a copy of the data here, and then instead of linking it to this slave, you link it to the master. And so for that, if you want that, you have to get the show slave status, or make sure you're taking a snapshot of the data directory, which has master.info in it, which has all that information in there. So you could do either of those. I like to get all the information as possible, just in case, because sometimes you never know what you're going to use your backup for. So in this case, if you're specifically saying I'm making a slave of a certain machine, that's one thing. If you're just doing it on your nightly backups, it doesn't hurt to get all the information, because show slave status and master.info is not it's not a lot of data. You're talking bytes of data. So MySQL dump, it's an export tool called MySQL dump. If you want to do it can do an entire database. You can do tables or whatever. In this case, we're thinking of how would we set up a slave. So how would you do it with MySQL dump? So this is how you do it with an entire database, right? You just put the database name there. So basically any the first option that doesn't actually have some kind of like -p, -u, anything that doesn't have a flag, is the first one is considered a database. The second one is considered a table name. If you have 3, I think it doesn't like it. So you can specifically specify multiple tables or multiple databases, but there are specific options for that. So some of the important options are -- databases. So you can have -- databases and then a list of more than one database, just a space separated list. So you can say MySQL dump -- databases, MySQL space test space production space, whatever your databases are named. You can do -- all databases, which I think is the --A is the short form of that, which will get all the databases. Single transaction is important to basically have that consistency. And then --opt will add a drop table, add locks, it gives you create options. If you don't have create options, you don't get MySQL specific create options, which includes things like storage engine, kind of important. Auto increment, very important. Disable keys, extended insert. These are so add locks, disable keys, and extended insert make the import go faster when you're doing that. And locked tables is what helps make it go faster. And then quick and set char set. So again, if you want to be able to have the same character set that you're getting the data from, and quick will actually, if you have data that's bigger than your RAM, which most people do, you want to use quick. And what quick does is it will write it to standard output instead of leaving it all to wait in the buffer. So it buffers a little bit, then writes standard output, buffers a little bit, writes standard output. So you get almost a stream, kind of. It's not really a stream, but you can think of it as one.
Why is that not the default?
It is the default. --op is actually the default.
Oh, okay.
So you would think, why isn't create options the default? It is. Lock tables, I don't know if that's in here. So I can just delete that from the slide because it's redundant.
Don't do backups while your database is actually running if you have lock tables on.
Well, if you do, okay, so if you do have a lot of stuff going, MySQL dump will lock your tables. So you do want to be careful of that.
Not if you use single transaction.
Yes and no, but it's not. But it's only for transaction-safe databases. So yeah, and it will actually take time to export all the data. And so if you're trying to write to a table, or at least even to a section of a table, and you're exporting it, it's gonna lock. It's not gonna lock, but you're gonna have to wait. So, because you can't have more than one write lock on, say, a row at the same time.
Well, what I've noticed happens on our database is that with single transaction, it will get the number of records that it had when it started, but it won't get any ones that were appended after the dump started. So it's basically, like, say it's at position 800, and then you add 801, 802, 803. By the time the dump is done, you're still only going to get 800.
Right, but that's for inserts or updates.
Right. Yeah, we're not deleting anything out of that
Right,
database.
yeah. If you have updates and deletes, it's a different story. But yeah, if it's just inserts, then absolutely.
I thought single transaction was reading the transaction log, so it would. Maybe I'm crazy.
Only for transaction-safe databases. Only for transaction-safe storage engines. So no, you're right. But it's all right. Your brain was somewhere else at the time. It's okay because there's a lot to think about when you're doing this. So. There's also, in 5.1, there's an option called master data, which writes the binary log file name and position to the output of MySQL dump, which is useful. And then in 6.0, which nobody's there yet, but in 6.0, eventually there's an option called dump slave, which writes the master information of the slave being created. So again, that's our two things to think about: the show master status. In 5.1, you can use --master-data, and it will get that information. And for show slave status, it's --dump-slave, but that's only in 6.0, which nobody's using. So there's a lot of options to MySQL dump. MySQL dump --help will show you all of them. It's useful to go through and see. I go through every so often because every so often there's a new option that I didn't see. For example, this is not on the topic of making a new slave, but there's MySQL dump --ignore, so that all the inserts are insert ignore, and there's also --replace, so that all of the inserts actually change into replaces, which is useful. And insert ignore happened a while ago, and replace happened, in the last year or two. So it was something that, I was using insert ignore, and I really wanted replace, and so I was doing other things, and then one time I looked, I'm like, oh, they do have replace, finally. So. If you want another hot option, to be hot backup is another hot option. Whenever anybody asks, what do I think Oracle will do with MySQL, do I really think that it will kill MySQL? I say no, because they're making probably more money off of to be hot backup than anyone is off of any other thing MySQL. to be hot backup is a commercial tool. Oracle owns it. It's a company called Enobase, which owns it, but Oracle bought them. The tool costs something ridiculous like €500 for a 1-year license and €1,400 for a perpetual license or something. But it goes on hostname, so you buy it once and you're done, pretty much. There's a free alternative from called Extra DB Backup, or Extra Backup, I think, from the Percona folks, which is very similar to DB Hot Backup. So basically, I'm just going to go through DB Hot Backup and say Extra DB Backup works the same, pretty much. So So by default, the InnoDB hot backup program itself, it's called IB Backup, doesn't only backs up InnoDB tables, but there's a free wrapper script called innobackup.pl, which backs both up. Basically, here's how you use it. Basically, Perl innobackup -- user equals username. So let's say root or backup user, password equals password. You can set it to compress if you want. There's actually like 9 different levels of compression. You don't have to put compress if you don't want to. This is just taking from a client that specifically that we have. etcmy.cnf is your etcmy.cnf, so it wants to know the config options and where to look for those because it uses them. And then this is where you're going to back stuff up to. So it's pretty simple to use. And let's see. So to restore, what you end up doing is, see here, you end up uncompressing. So if you're just taking a one-time snapshot to make a slave, I don't know if that I would do compress and uncompress. But you know, if you were doing it, you would say, here's my IB backup. So now I'm going to apply the log. So how InnoDB hot backup works is, it looks at the InnoDB log. It looks at the log position and the transaction position within InnoDB. So what it does is, it's hard to say, but if you ever looked at show InnoDB status, you'll see that it has like transaction points and it has checkpoints and things like that. So it looks in InnoDB to see where it is in that. So basically, what transactions are finished and what transactions are started, and what number am I on basically in the transactions. And what it does is it records that, and it saves all of the logs that happen between and it does a copy. And it saves all the logs that happen between the time it starts and the time it finishes, and then it has that in its log. So apply log is basically getting it to that point where it's going to be consistent. Until you do the apply logs, you don't actually have a consistent backup. You have the makings of a consistent backup because you have the data and the log, but you don't actually have the consistent backup. It's not a huge deal because, you just do it either way. We actually have one client who has they do what they call refreshing their data. So they take a backup of production every week, and we do this automated for them. It's just automatic. Every week, a backup goes from production and goes to their development environment and just refreshes. So what we do is we stop the development environment on like Friday night at like 9 p.m. We stop the development environment. I believe we've already applied the logs and copied the log over. So we just move the stuff. No, we've applied the logs, we haven't copied it over. So we copy it over, and then we move the data to the right data directory. So we move the old data directory aside, just in case we have to go back to it, and then move the InnoDB hot backup we've just applied the logs for back to that data directory, and that's it. So you're getting these physical files, you're getting IB data files, the .frm files. It's going to copy all of that. So, and you have to give it the etcmy.cnf because it has to know how big to make these like data files and all that kind of stuff. So here's just the contents of etcmy.cnf if it's really that important, like the InnoDB log file size, log group home directory, that kind of stuff. This has to be accurate, and it's going to restore to these places. So what we actually end up doing is when we restore, we actually don't use etcmy.cnf. We've actually used a program that will translate some of the directories, so we have kind of this fake my.cnf such that we restore to a separate directory, and then once that restore is complete to that other directory, we'll then move the files to the right place, because we don't want to end up deleting what's currently there on even though it's development. We don't want to delete it until we know we have something that's right. So the documentation is, innodb.com. You can find documentation. InnoDB Hot Backup has a 30-day free trial. They do take like your email address and whatever to give you that, and then they email you a file with a 30-day free trial. So which we've used when we're like, oh, we just need a backup to make a slave.
Sorry, I think I missed something. So what does this do that a normal MySQL dump will not do?
So this is a hot backup. A MySQL dump will lock your tables for the amount of time it takes to export things, or if it doesn't, you need a single transaction. But it still takes a long time because you're logically exporting the data. This is a physical copy. This is the IB data file. So you don't have, when you import it, you don't have to actually import, like with a MySQL dump, it's a logical export, so you have to import it. With this, you just copy the files in place and you're done.
So this is as good as stopping MySQL and physically copying the file?
Correct. It is as good as physically stopping MySQL and copying the file, except that your database is online the whole time. Now you could call it like a warm backup because it does have to do this, apply logs, and while it's copying, it does take resources. But I mean, you can think of it even similar to the snapshots, where you take a snapshot and then you're copying it over. That's exactly what have backup does. It's taking, it takes it doesn't take a snapshot, but it says, okay, here's where I am in the transaction logs, starts copying the files, and then you have to apply the logs to finish it up.
So is it a one-time thing, or can I sort of, is it possible to sort of keep copying transactions after the initial data has been moved?
Well, once you have a consistent snapshot, right, you're only going to get a consistent snapshot for that one point in time. However, the binary logs are your incremental backups. So if you wanted to get, like if you have backups at 6 a.m. every day and you wanted to restore it to noon, you would restore your have backup and then start, apply the binary logs from 6 a.m. till noon. So extra backup, which is, I said, works similarly and it's completely free. It doesn't do compression, so you forget the dash compress and dash uncompress. You can actually, it works by streaming, so you can actually stream it into like gzip or whatever if you really want to compress it. So, and we haven't had good, we have unfortunately not had good results trying to stream it into SCP, but apparently they say you should stream it into Netcat, which is okay, but I feel like it's, they're like, oh, you could just stream it to copy, and you're like, yeah, but not SCP, which is what everyone uses to copy. They're like, well, Netcat, but that's not secure. It's not encrypted like SCP is, but it usually doesn't matter because usually you're just doing it right on the same, VLAN or whatever. But I don't think many people know about that. That Netcat is suggesting SCP just doesn't really work very well. So.
I think SCP tries to figure out the size of the file before it starts transmitting it.
It's not quite that. It works, but it just the latency is huge, and it just doesn't. And maybe it could
I've
be
never
related
gotten
to
it to
that,
work.
but
Not
yeah,
reliable.
it doesn't work really well. So Netcat is better. MySQL Hot Copy is another hot backup tool. It only works on MyISOM files, and actually that's what the InnoDB Hot Backup wrapper script uses to copy MyISOM files. Well, actually, it just uses SCP. It just uses CP. Does a copy on MYI, MYD, FRM files, all that kind of stuff. So MySQL Hot Copy, if you're only using MyISOM tables, then use this tool. It basically does a lock table for read and then copies all of the MYD and MYI, not MIY, files to the location that you specify. So you do something like MySQL Hot Copy, database name, and then the backup directory you want it to copy it to. And you can look at the options and you can specify all the databases that you want to use, all that kind of stuff. So you have to be using MyISOM only. We actually have, I think, at least one client who uses MyISOM only, so I think it's actually only one client. But we've had a few in the past too that are using only that, so it's, there might be maybe 5 to 10% of the people out there are using only MyISOM, so it's not as bizarre as it could be. Let me make sure I've said everything in my notes. I think I have. One of the things that's neat is that like the database name and table names end up taking regular expressions, so you can really kind of heavily configure which databases and tables you take. So cold backups. First you shut down the MySQL daemon, then you copy or archive the file, so if you want to put it in a tar file or whatever, that's how that works. So it's not as desirable because it's a cold backup, right? You have to shut down MySQL, but you might have a backup server that you specifically do that. One client that we have, I may have mentioned it before, they have all of this stuff's on Amazon EC2 instances, and they have one Amazon EC2 instance that has 13 MySQL instances on it. So it's MySQL D-Multi, they have 13 different ones, and each one is a slave. And the express purpose of this server is to keep all these 13 slaves running, and every hour or two it shuts down one of them, takes a copy, takes a backup, takes a cold backup, just tars up the data directory, copies it over to S3, and turns on the slave again. Just starts up that instance again. And it's just a very pretty inexpensive way if you have an extra server or have that capability. It doesn't have to be the same hardware as your master. If you're using it just for backups, it just has to be some kind of a server that's not really being used, doesn't matter if MySQL's up or down. And you just, again, physically copy the server. You can do it with scripts, you can automate it with Perl scripts or shell scripts or whatever. You just have to be able to stop the database, copy files, start the database.
So the whole data directory you just copy and that's it.
Just copy the whole data directory. We also copy the binary logs and make sure you get the master.info in there. So not just the data directory, but also not just like the databases themselves, but the master.info. You could do something like rsync to keep things in sync without copying all the data. You might have data that's not changing very much or something, so you might want to rsync it to get those diffs or whatever. It doesn't really matter. So things not to forget, if you are making a backup, in general you want to make sure you're getting a backup of my.cnf because that's really important. Your slave is probably going to have similar similar parameters to your master, so that's important. Any triggers, views, store procedures, that's something if you're doing like a logical export with MySQL dump, you want to make sure you're getting. Store procedures are stored internally in the MySQL database. Triggers are stored in the database in which they are assigned to. Triggers are assigned to a table, so that table is assigned to a database. The files are actually like .trg and .trn. So if you're doing like a physical copy, make sure you get, don't just copy MYI, MYD, FRM. Make sure you get TRG, TRN. Best to just copy the whole data directory if you can. Any cron tab scripts, MySQL events, all that kind of stuff. You want to make sure you have users and permissions. So that's in the MySQL database. And then binary logs are usually good to have. Usually, if you have a consistent backup, you don't necessarily need the binary logs. It's good to have them as the incremental backup. So it's good to back up the binary logs more frequently than you do a full backup, because binary logs are your incrementals.
So you could also back up the MySQL database, right?
If you back up the MySQL database, then you don't need the incrementals because it's full. So the bin logs are an incremental. But you want to make sure that you are backing them up at some point in time, because otherwise, if you're not backing up your incrementals and you lose your machine, then you don't have your incrementals. Other recommendations, if you're going to lock tables or otherwise put a lot of strain on the machine, choose a non-peak time, especially if you're using MySQL hot copy, because again, that uses copy. It uses a OS level, like a CP kind of a thing. The LVM and ZFS options provide low overhead and don't really impact performance greatly. Again, if you're using SCP, it might. If you're doing a lot of compression, it might. But all of them would have that. If you end up compressing a cold backup, it ends up using resources too. Now, I don't actually have here a slide on how to set up the slave, but once you have the slave, once you have a machine that's the same copy of it, and you have the master info, right, what log position and what log file, you just do change master to master host equals hostname, master user equals username, master password equals password, master log file equals log file name, master pos equals a number, so the position. So that's all you do. You change the master, you start slave, and hopefully it works. If not, check the error log, and you'll see what happened, what's wrong. Either the log file isn't there, or because that's another reason you want to keep your binary logs. If you end up trying to create a slave and the master log file isn't there, you can't actually start that slave. The log file has to exist on the master when you're saying master log file equals blah, because you're starting from that position. If that file doesn't exist, that position doesn't exist, it can't start. So that's about it. A lot of times, usually permissions too. The master needs to make sure that it gives the permissions to that slave, because you have it on slave 1, right? But now you're making slave 2. So maybe you've allowed replication user at slave 1. You have to allow replication user at slave 2. So those are the two biggest problems that usually end up happening. So what causes a slave to get out of sync? So here's the thing. The main reason is statement-based replication. So statement-based replication, which is the default until MySQL 5.1, I think it's 5.1. Yeah, 5.1. So what happens is you have your binary logs, and what gets logged to the binary logs is a statement, right? It's only the statements that could possibly change the data. So update table set foo equal to bar where something equals baz. All right, so that's an update statement. It's going to change the data. That actual text gets written into the binary log file. With row-based replication, what you end up getting is data. You get data blocks written to, I don't know if they're blocks, but they're certainly data. You get chunks of data written to the file. With mixed, what you get is, now so the benefits of statement-based is that it's really short, right? So if you update 1,000,000 rows, it's still the same statement. You update 10 rows, it's still about the same size. With row-based, you update 10 rows, you get 10 rows of data. You update 1,000,000 rows, you get 1,000,000 rows of data. There's a lot of more latency with, you know, network bandwidth and all that kind of stuff. But with row-based data, you're more accurate, right? Because you don't have any problems with data that is different on the master and on the slave. So if you have some non-deterministic data, that can be different on the master and the slave. There's also mixed mode, and mixed mode is, it does statement-based unless there's a non-deterministic function in there, and then it will do row-based. So you kind of get the best of both worlds there.
So in 5.1 you can do pure row-based?
You can do pure row-based.
Oh, okay.
In 5.1, and you can do pure, so you can do pure statement-based in any version.
Yeah.
It's from 3.23 on up. In 5.1 you can do either pure row or pure mixed, or mixed.
But not 5.0.
I don't think you can do it 5.0 now.
No.
I seem to recall it's a 5.1 thing, because what they ended up doing is in a pre-release version, an alpha version that they were using internally and also gave to some customers to test, they actually changed the default to be mixed, right? Because why wouldn't you use mixed by default? It's the best of both worlds. What they found was people have actually taken the fact that replication might not be safe, statement-based replication might not be safe, and have used that on purpose. So if you want to see, for example, how long your slave is lagging behind, you could have something that every minute, like from cron on your master, every minute puts a time into a table and uses that time as sysdate. So sysdate specifically is not replication safe. Current timestamp is and now is. But sysdate by default is not. So you can do that. You can say, okay, use sysdate, and you can see, let's say, latency, or you could get different times if you have one server on the East Coast and one server on the West Coast, and they're both local time, right? You end up being 3 hours apart. But a lot of people have made kind of tricks like this to say, or what user did this, and so they'll insert the current user. And current user, again, when you're on the slave, the current user is system user. When you're on the master, the current user is whoever is doing that command. So a lot of people have actually done that, statements that aren't safe for statement-based replication on purpose. In fact, one of the tools that we'll look at actually has done that. So in order to checksum the data, you're actually using statements that aren't safe for replication, because you basically want to run a checksum of some data on the master and a checksum of the same data on the slave, and be able to compare the two answers in one database.
So what are the other examples of non-deterministic?
So, well, I'll give you a few examples of things you might think are non-deterministic, but actually are deterministic. So one of them is auto-increment. That's something that specifically is put into the binary log. I said now and current timestamp, those are deterministic in terms of replication. What else? Sysdate will be deterministic if you use the specific option sysdate is now. So basically then it makes it an alias to now. So what else? Rand, if you do like anything with a rand function, that's actually deterministic. It puts MySQL puts the seed numbers into the binary log. But things that might not be are like, if you do a count of a table, for example, that might not be the same on the master and slave. Most functions that you'd think of are, and again, they have kind of made special allowances for frequently used statements that aren't deterministic, like random or now or auto increment, inserting into an auto increment. So they've done that on purpose. So most of the time you should be okay. But if you look at like the MySQL manual page for that certain function, that's probably the best thing to do, because it will, say this is not safe for replication. In 5.1, you'll also get an error into the error log, or a warning into the error log. I forget which, probably depends on your SQL mode, that says statement not safe for statement-based replication, if you're using statement-based replication. If you're using mixed, replication, then as soon as it sees a statement like that, it's gonna make it row-based, so you don't have to worry about it. So why would a slave get out of sync? Well, if you're using statement-based replication, you have these non-deterministic things. We've actually had people using sysdate because that's an Oracle thing, and so people are just, they're using it and they didn't realize that it was different. We actually had something where all the times were 3 hours off because they had one slave on the one master on the East Coast and slave on the West Coast. Network errors. When it says it's hard to prove, it's actually hard to prove because, like, when you lose a packet, you're not losing like the entire query, right? So there should be some kind of TCP/IP should have some kind of error and fault tolerance. Sometimes it just doesn't. So it's hard to prove, but we've been able to actually, on clients that don't have any non-deterministic statements, and they don't have any human errors like somebody updating data on the slave by mistake, and still replication will get out of sync. It doesn't get out of sync very quickly. It just kind of gradually, over a couple of months, will start to lose. And the problem is that once you get a little bit out of sync, like let's say one row doesn't make it to the slave, you do an update, and all of a sudden, now you're only updating one less row, and maybe there's, some kind of count that goes there, and all of a sudden, once you have one, it kind of will snowball. And again, it's still a very slow snowball, but if you've been working with your database for 5 years and you've never checked the integrity of your data, you might see a lot of differences. Also, if you have different versions on your master and slave, you can see differences. I've seen floating point numbers be different on different versions, like where it rounds to. And because floating is floating point precision, you're not guaranteed to have the same precision. But some people are using floating point for like, oh, this is how we measure things that we bill people for. And on the master and slave, it was different by 0.0001. One said 0.007 and one said 0.008. And they were like, well, which one's the right one? And we're like, well, you're talking about a penny difference in what you're charging them, but you should decide which one. And we've eventually figured it out that the reason it was doing that is because there were different versions on the master and slave. And it was different minor versions, like the slave was 2 minor versions ahead of the master, but for some reason that affected the way it rounded the floating point stuff. So that can cause the slave to get out of sync. Also, missing temporary tables. So at the end of a binary log, your temporary tables will go. If a slave crashes in the middle of doing something with temporary tables, those temporary tables go away. All the in-memory tables go away. So if it's restarted, it might actually end up having lost data because it doesn't have those temporary tables. Dependencies on non-replicated data. So if you have something that's loading data in from files or something, and the files are different on the master and slave, that kind of thing. And then if you have the same server ID on 2 or more slaves. So the way replication works, and the way that it avoids, like if you have circular replication, the way that it avoids applying the same change over and over and over is that in the binary log it actually saves the server ID. So it says, okay, this is from server ID 1. And the slave, which is say server ID 10, doesn't have to be 2, it can be 76, says, oh, okay, what's this server ID? 1? Well, I'm 76, so this didn't come from me, so I'm going to apply it from 1. So if you don't have that, then you might end up, if you have the same ID, then you're going to end up not inserting things that should be inserted. If the master and slave are both 1, server ID of 1, first of all, replication shouldn't start and it shouldn't work, but just in case you get there, you can have problems like that. One problem I know that we had is we actually had one of those queries running around and around and around when a slave wasn't up to date and somebody changed the server ID on the slave. And so that slave, let's say it was 76, got changed to 2, so there was an ID of 2 floating around there, and it was a master-master setup, so it kept going back and forth, and it kept inserting the same row over and over and over. Yeah?
The first one, so if you tend to use a lot of temporary tables for things, slave gets restarted. If there's another statement on your master that was relying on those temporary tables, what will happen on the slave? Will it just say, or will it try to roll back and build the temporary table for an earlier point in the log?
Well, hopefully if you're shutting down, it's going to do, if you shut down cleanly, it should either finish the statement or roll back. So if you do have transactions, if you're using transactions and you not only have to use transactions, but you have to have a transactional database. So if you're using MySQL tables, it doesn't matter using transactions because it doesn't make a difference. However, if all that is set and you're using transactional storage engines and you have and you're having in the middle of transactions, you shouldn't have a problem if MySQL does shut down cleanly. So if you do MySQL admin shutdown or something, or you do etc init MySQL stop, MySQL should finish applying the current statement on the slave, stop the slave, and do that normally. So you shouldn't necessarily have a problem, but if it crashes, it'll have a problem, or it can have a problem. So how do you sync the slave with the master? So first of all, you need to determine if they're not in sync or not. So how do you determine if they're not in sync? We use mk-table-checksum, which is a matkit tool, which Baron Schwartz wrote, and now I guess Percona maintains. And it's a pretty good tool. So this is basically how you use it. You download it from matkit.org. You do Perl mk-table-checksum. -- replicate equals a table, database and table. So matkit is the database, checksum is the table. What this says is, I want you to replicate your changes, right? I'm going to do it on the master, and it's going to replicate to the slave. And we're going to use this table later to see the results, to see if they're in sync or not. So what this will do is it will take checksums of the data. It doesn't tell you if things are in sync or not, but we will take checksums of the data and put it in this table, and then you can query the table to see which data is different. So algorithm equals bit XOR. There's a few different algorithms you can use. There's a checksum algorithm, which just checksums the whole table. There's bit XOR, which we found to be pretty good. There's actually another one, I forget which one it is. But if you read the manual, you'll see there's basically one is, a little more like, because with checksums you can actually get false positives. Things are the same even when they're not, because it's just a checksum, it's just a hash. So there's one that works in more cases but has more of a chance of false positives, and then there's one that works in fewer cases, right, but has less of a chance of working that. And if you specify, the one that you specify is the one it's going to try to use by default, but if it doesn't work, it will go to use the other one. So you won't really get an error that says, I can't use this algorithm, try another one. And if you do, then you could try another one, but I don't think I've gotten that problem before.
Does this lock the tables that it's looking at?
Does this lock the tables it's looking at? Yes. What it will do is it actually locks. So this, the bottom says you can also specify chunks. I didn't here. So this will actually lock the tables while it's doing a checksum of it. If you specify chunks, it only locks the chunk. So that's pretty good. So, just to finish here, again, your bare word here is going to be your local host. It's going to be the machine that you do it on. User equals root, and then ask pass will ask for your password. Or you could say, -- pass equals password. So this is your basic, how do you do it? You don't need to specify the algorithm. The only things you really need to specify besides mk-table-checksum are the replicate. So it's gonna, it's gonna actually put the stuff into this table, and it's gonna replicate. Localhost, and then user and password. So, how do you connect host, user, password, and then this is, replicate it, which means this is the master. There's tons of other things you can specify that the slave shouldn't wait. You can do it on the slave and say don't wait for the master to actually be up to date, that kind of thing, if you don't have a lot of different changes. This is basically what we use in production with a lot of our clients, is to run this on the master, and then it will just replicate onto the slave. So here's how to do chunking. So chunks use numeric indexes, and dates and times count as numbers. So if you have a primary key or even a regular key, regular index, doesn't need to be unique or primary, on a date, a time, a number like int, big int, small int, tiny int, you're golden. You can use chunks, and it's great. So Perl mk-table-checksum. So we had this replicate here equals matkit.checksum, algorithm bit XOR. We had localhost at input user and password here. But here we have modulo 21, chunk size equals 1,000, and offset equals 7. So what this does is it splits the data into 21 different pieces. So if you have a table that's 2,100 rows, right, or say 21 million rows, right, it's going to split it into approximately 1 million rows each. And what this chunk size does, chunk size 1,000, is it says, okay, I'm going to checksum these 1,000,000 rows, but I'm going to do it in chunks of 1,000. So it's only going to lock that 1,000 rows at a time while it does that checksum. And it's going to be very quick, well, a lot quicker than locking all of the things and doing a checksum of 1,000,000 rows. Because even doing one operation, right, a checksum on 1,000,000 rows, that's a lot of data to have to checksum. Doing a checksum on a smaller amount of rows is good. And then the offset is 7. So here we're doing part 7, right? You might start with part 1, then go to part 2, then part 3, then part 4, up to part, if I started at 1, it would be part 21, and then go back to 1. Or if I started at 1, it would be part 20, and then go back to 1. And again, localhost. If there is no numeric index, it will checksum the whole table. This is unfortunate for some clients that we have that have very large tables that are using like primary keys as GUIDs or UUIDs. So, and they don't have anything else indexed. That's a number. You know, it could be a date, it could be a time. Doesn't matter if your primary key is a varchar, as long as you have some kind of index, because that way mk-table-checksum can say, give me, you know, the first, you know, 5 rows or whatever. Let me see what's the lowest value in the index, right? Give me the minimum value, and then give me the maximum value. Now I'll divide that by 21. Take the first, you know, well, I'll take the 7th 21st part. So I'm going to take, you know, row 7,000,000 to row 7,001,000, right? It can't really do that with characters. The only way that it can do that is with order by and limit, which isn't so great. Theoretically, it's supposed to be able to do that with the order by and limit, but it doesn't. It actually was put into the table sync tool, but not in the table checksum tool. And there's an open bug on that, which is, I guess, being worked on. I guess they're trying to figure out how to kind of put that in. It's not trivial. I've looked at it myself because it's all open source. So you'd think you'd be able to just slap that right in because it's just a, you know, it's kind of a modular function, but it's not quite that modular. Which is, you know, it's a little frustrating because it's like they've already done the work to put it in the tool, it's just not in the right tool. So mk-table-checksum, there is a -- create replicate table on the first run. Otherwise it'll try to insert into a table that doesn't exist. But pretty much when we do this, we have something like, hey, modulo 21, we've got, let's say, 100 gigabytes, well, not 100 gigabytes for modulo 21. We might have like 20 gigabytes of data. And so we found that chunk sizes of about like 1 gig. So if you have 20 gigs of data, we'll divide it into modulo 21. We'll do that because if you do something like that, then you do 1 chunk a day, or 1 offset per day, and then you end up, you know, syncing, making sure your data is in sync every 3 weeks. So every 3 weeks, you've gone through all your data. Now that doesn't necessarily mean that at one point in time all of the data is synced. It just means that if you have any problems, they're going to be less than 3 weeks old, because you've already checked. You checked the data on November 1st, and then November 22nd, you're going to check the same data again, or that same chunk again. So it's not perfect. You can use mk-table-checksum to do a one-time checksum. You know, and it might take a few hours and it might lock your tables and whatnot. Most people prefer to do the chunking. You don't have to. If you have downtime or you have time that doesn't matter, that things are locked, you certainly can, you don't have to use the modulo offsets or chunk sizes. You can use the chunk size even if you don't use the modulo or offset. But what we basically found is, you know, most clients do it like this and they're great. You just have to be careful about tables that don't have any numeric indexes. And unfortunately, they're out there. And if there's no numeric index, it will checksum the whole table. It's actually there twice on purpose because it's really, really important. You don't want to find it out the hard way when your checksum has been running for like 3 hours and you're like, oh man, it's creating load and locking stuff that I don't want to lock, because it's checksumming the whole table. So it will in fact create a table and store information the way that we've done it here with the -- replicate table, and then define the data that's not in sync. Right? You find the chunks that aren't in sync, but basically the tables that aren't in sync. You query that table. So after it's done, you can query the table. So what we have ended up doing is we actually have a cron job on the master that will run, you know, whatever it is. And then some, you know, some clients, you know, this 1 gigabyte of data takes maybe 10 minutes or less to do. So we run it a few times a day. So for clients that have a couple hundred gigs, we might end up doing it something where if you run it 6 times a day, then in a week your data will be synced. So that's 42. Or maybe if you run it 6 or 7 times a day, in 2 weeks all the data will have been checked. So there's there's some magic numbers. 21 is a magic number. I think 443 is a magic number. Divide that by 7, you'll figure out what magic number it is. Because it's basically like in a certain number of weeks, have you checked all that data? So here's how you checksum the table. So this is actually checksum 1. It's actually happens to be something that we took from reduction. Pretend it's actually matkit.checksum. There we go. Now you don't have to pretend. So the database is production. Table is food. Chunk is 1176. That's the chunk number, right? So now this is in. It's doing this chunk with this offset. Say offset of 7. The chunk of 1,000, right? So it's on this chunk 1176. Here's the boundaries. This is huge here. So this is what it is, and you can see this CRC, this is the checksum, master CRC. The checksums are different, right? So we said select star from checksum where this CRC does not equal master CRC. If you're lucky, you'll only get 1 row. You may want to say where this CRC does not equal master CRC and DB does not equal MySQL. Because if you have different permissions on your master and slave, which you very well might, you might basically have something from the master allowing the slave to replicate, but you might not have that same thing on the slave. And even if you did, if you allowed the master to do it, they might have different IP addresses, right? So you'd have to have the exact same stuff. So a lot of times we have, we have something like that. The other thing is this is the matkit. This is in the matkit database, which we created specifically for this checksum. The checksum tables might not be the same. Like this actual table, checksum, might not be the same. Once you run this checksum once with create replicate table, the next time you run it, it's going to checksum this table, which may be different on the master and slave. So again, that's something you might want to say where DB not in MySQL, matkit, things like that. Or you could say where table not in checksum, whatever it is. So you can see the count is different too, 295 versus 245. Obviously, if the count is the same, you have the same number of rows and a different amount of data, different type of data. It could be, but again, you have it between these 2 IDs. So, and this is the timestamp. This is when it was done, 11/8 at 1623. This is really fascinating because this, oh no, I did this, I might have done this yesterday or something. Anyway, I was going to say these slides were made like 4 or 5 months ago, so that's pretty amazing that you're just picking a random time, but I think I redid this example. So if you find that you have this, what I would do on my master is I would say MySQL dump, from this table where ID is greater than that or ID is less than that. So there's the -- where clause to MySQL dump. So you say -- where space, quote, ID is greater than that and ID is less than that. I would run that both on my master and my slave and then do a diff. I would do one thing I use skip extended output, which puts 1 insert per line. And then I can do a diff, and it's a line by line diff that says, okay, is this line in this table, is this line in that table? And then whatever comes out of the diff that's not in there, you can just say, okay, what's not on the master, or what's not on the slave that is on the master? Okay, now I'll just take those insert statements and insert them to the slave, and vice versa. Now again, you have to be somewhat aware of your data, because if you see that there's data on the master that's not on the slave, or vice versa, data that's on the slave that's not on the master, you have to figure out, well, why is that? Is that just a mistake, or was that done on purpose? We actually found like some clients had like one table that was just completely different. Every single row was different. And so when we did a diff, we got 5,000 rows or whatever, because we looked at 5,000 different rows. So we looked at like 1 or 2 of them and did really like a line by line what's different. And we saw that one of them had their ampersands escaped as if it was for a web page. And so we asked the client, we're like, is this on purpose? Do you need this? Because the sync checks are going to come out wrong, and there's no real way we can check those tables to see, hey, are these only certain columns in sync? Now, mk-table-checksum may have something that can do specific columns. I haven't looked recently. But for all intents and purposes, for what I know, you can't do that. And they actually said, no, we needed it for templates a while ago, but we don't need it now. So that's actually a case where there was different data there on purpose. There was actually a trigger on the slave that was not on the master. and that was done on purpose, but, you know, they didn't even need that anymore. So they didn't even realize their data was out of sync, you know, on purpose, and yet it was. So it's actually a pretty neat tool, and you can see, because it has this CRC and master CRC, what it does on the master is it says, you know, it gets the checksum, and then it says, okay, the checksum is F91 AFA 73, put that into master CRC. Then the count is 245, so insert into, you know, mk-table-checksum, master CNT equals 245. What it does with this .cnt is it says, okay, now do a count of this table and insert that into this CNT. So on the master, these always match up. Master CRC and master CNT always match this CRC and this CNT. So this tool is actually taking advantage of the fact that in statement-based replication you can have different data on the master and slave. Because on the master, this CRC and this CNT is different from what it is on the slave, or potentially different, right? So in this particular master slave, right, the master CNT would be 245, and this CNT on the master would be 245. This CNT on the slave is 295. So it's actually taking advantage of the fact that it's not a statement-based, it's not safe for statement-based replication. It's actually using this on purpose. So we talked about why might you use it on purpose. Why might you want different data on the master and slave? This is one reason you might want different data on the master and slave, because here you actually want to see if there's different data on the master and slave. And the only way to do that is to run some kind of function that runs differently on the master and slave and then compare. So I think it's actually a very clever use of replication by, you know, Baron to make this tool. So it's kind of, I think it's pretty neat. When mk-table-checksum fails, so if a suitable key can't be found, and of course it's not free from bugs. If you can't actually use mk-table-checksum, you could just use MySQL's checksum table. Again, that will checksum the whole table. Or you could use MySQL dump, order by primary lock tables, do on both servers and do a diff. Questions? Okay. So if it can't use an index at all, again, it's not necessarily going to fail, it's just going to do a checksum of the whole table. In boundaries here, first of all, it'll take a long time probably, and in boundaries here you'll see where 1 equals 1, which means it does the whole table. You'll see that if the table is less than your chunk size. So if you have a table with 900 rows and your chunk size 1,000, the boundary is going to be 1 equals 1, because it's checksumming the whole table. So it's not necessarily a bad thing to see 1 equals 1. It means it's checksummed the whole table. But if it's, you know, if it's taking a very long time to do the checksum, you can actually see the query by doing a show process list. You can see the query and see that it's very clear, because it uses a comment to say, you know, replace into, you know, and it specifically says mk-table-checksum, you know, and it will do a CRC on a certain table, so you can actually see what it's doing.
So in this case, both the master and slave have to be in the same server instance, right?
No, in this case,
So they could be on completely different machines?
Yeah, they can be on completely different machines.
So how is the statement for the MAC-kit database, does it then exist with the slave?
No, so the question is, how does the master information stay the same on both? What it does is it says, it'll take the count, right? Let's say the count is 245.
Yeah.
So it'll say insert into the table, set master count equal to 245.
Right.
Where for this, it'll say insert into table, set this count equal to count of table.
Oh, I see.
So it's actually putting the number or the string in the case of the checksum, you know, the literal number or string in master, and then it's a function in this.
In this one, right, okay. Now I
And when it replicates, the database is supposed to be consistent at the time of replication, right? So you don't have to worry about, well, did I run the checksum when, you know, before this, you know, it was inserted on the master but not yet on the slave. You don't have to worry about that, because the replication is serialized. So you know that it's supposed to be at that point in time supposed to match the master. If it doesn't, it's because you have a problem.
So you would look then at the MAC-kit database on the slave.
Yes,
Do your
so
comparison.
this query is running on the
But,
MAC-kit database on the slave.
master's not gonna have complete
Right.
data.
If you do it on the master, you'll never have a problem, because the master is always
Right,
going to be
it's
the
just
same.
universal.
If not, then there's a problem with the checksumming feature itself. Right, the count isn't returning the same thing at the same time. So yeah, it will always be the same on the master, so you want to run this on the slave. And for our clients, we actually have a daily check. We have like a special thing that we can run checks every day and, you know, put the output somewhere, and if the output is bad, then we have to click on it and look at it. So what we do is on the master we run the checksum, the mk-table-checksum, and then the slave we run this query, and then output, if there's anything bad, we output that. So again, when it fails, it doesn't actually like fail and die, although it does have times when it does that, like if you don't give it the right username and password or whatnot. It will just checksum the whole table, which is usually not desirable. Okay, so let's say we know that there's a table or some data out of sync. Now what do we do? Well, you can do the diff, as I was saying before. You can do a MySQL dump, -- skip extended insert, compare the two, you know, on the master, on the slave, compare the two, and then insert into the master slave what's different. You can also use the mk-table-sync tool. Now this is the tool that actually has chunking in it. The nibbling, well, I didn't call it nibbling, but nibbling is what they call it when you're just, when you have like a character that has a key, and you can do the first 5, and you're kind of doing order by and limit. That they call that nibbling. That's actually in mk-table-sync. It's not an mk-table-checksum. So one thing you can do is you can try to use the mk-table-sync tool. You can use the verbose option to see what operations it's going to perform. So it just says, I'm going to checksum this, I'm going to checksum that, I'm going to do this, I'm going to do that. Use -- print to display the actual SQL statements it would use to sync the table. So you can actually let it run, and it will automatically sync the tables. Or you can be paranoid like I am, and you can do -- print, and what it will do is it'll say, oh, I wanted to insert this and delete that and update that. So we found that it's a good idea to save those to a log file. So once you look at those, you know, SQL statements, if they look good to you, go ahead and run that log file on the slave. We actually had this tool, well, more than once died. It over and over on one specific client did the same thing over and over. Died silently in the middle of actually syncing this. And it left inconsistent data, like even worse than it was before. We actually prefer to apply the logs manually, meaning we'll apply one update and wait for it to finish, and then another like insert and wait for it to finish, and then do that, just because we've done that. We don't use mk-table-sync anymore because it was too many problems. What we ended up doing is we'd run mk-table-sync with -- print, we'd update all of the statements, and then run mk-table-sync with -- print again, and it would show us the same thing. And we would like run the thing manually and look at it and be like, okay, I've done the update, I've updated 0 rows because they're already updated. And then we run mk-table-sync, and it would give us, with -- print, it would give us the same thing again. Now again, this is probably 6 to 8 months ago. It's really not a big deal because with mk-table-checksum, you get these boundaries that are really, really nice. So it's really not that hard to do MySQL dumps on both the master and slave, do a diff, and do that. And mk-table-sync may have come a long way. It may be better now, which is why it's still in these slides, because these slides were actually made like 2 months after we had used it and kind of decided, we're not really going to use it, but we wanted to keep it in there. And so again, I want to make sure that people know about it, because you know, we kind of used it when they started talking about it. It might be a lot better than even generally available, you know, stuff that's, you know, non-alpha, non-beta, when it first comes out, has, you know, more bugs than after people have used it and submitted bugs. So, I mean, I would say try it. Obviously, use the verbose option, use the print option. I don't like things that self-tune and you know, oh, I'll just fix myself, you know. I especially like knowing what's different, because we found a lot of interesting things. We found on one client, they actually have a table that has 1 row in it, and it's basically like a preferences table, and every day there's something that updates the slave to a different value. So like we actually synced it back to the master, and the next day it was different again. And we're like, we just synced this yesterday. We have notes in this ticket that we fixed it, and now it's back again. And the client was like, yeah, it's not that important, don't worry about it. So we just skipped, you know, looking at it. So when we said, you know, select star from checksum, we said where table, not in this one. So mk-table-sync doesn't always work right. If you see that it doesn't bring tables to sync, leave it and use another strategy. If there's only a few differences, you can use MySQL dump and diff to find and resolve them manually if mk-table-sync doesn't work for you. If you have 100 tables with complex foreign key checks, so this is another thing. Sometimes you'll find a table doesn't have the data and you try to insert the data, but you can't because there's a foreign key that's checking on it. It's like, oh, you tried to put it in a sales table, but this user doesn't exist. So then you have to go to the user table and do that. And we had a client that had like 7 levels of these foreign keys, and when the seventh generation child, had to be inserted, we were like, forget it. When we saw that there were 100 different, of these 7th generation childs, we're like, we're not gonna try to futz and see with every single one of these, and then get their parents and their parents and their parents. Just do a full refresh or a refresh of a particular table. If it's 100 tables, you might just want to do a full refresh. So again, take a backup, like we talked about in the beginning, restore it to your slave and say, okay, now it's fresh. Now it's right. It's right from this moment on. If there's one table that has a lot of different data, change, do a MySQL dump on the master, import on the slave, that kind of thing. There's just, there's no point in doing a one-off, like insert this, insert that, unless you're really doing that. And pretty much what we found is, after an initial sync of the data, which some clients have been, to our shock, have been very close to being in sync, to other clients who have like half the data completely different because they're using different versions on the client and server. We have one client that's completely just, the data is just all over the map, and their master is using 5.0 and their slave is using 5.1, and we pretty much think that's probably the reason. Like, we keep trying to fix some of the stuff, and then other tables go out of sync, tables that weren't out of sync before. So it's an interesting thing. So if you have a lot of tables, if you have a lot of data that you're going to need to do, it might be useful to just do a full refresh of the table or the whole data set. And that's it.